We can also factor binomials using what's known as the substitution property. Let x plus r equal capital A. In any expression, A can replace x plus r. So here's an example. We're going to factor this expression x plus 3 quantity squared minus 2 times x plus 3. Notice that both of these terms have a factor of x plus 3 in both of them. So let's let capital A be equal to x plus 3. Then we can rewrite our expression as x plus 3 quantity squared minus 2 times x plus 3. That is equal to a squared minus 2a. Notice you can clearly see that there is at least one a in both of these terms, so let's factor it out. And when we do that, we are left with a times a minus 2. Well, now we can substitute the x plus 3 back in to the expression where the a's are, over here mainly, because this left side is the same. So we have x plus 3 times the quantity x plus 3 minus 2. And then we can simplify the rightmost set of parentheses with the positive 3 and negative 2, add them together, and we will get plus 1. So we can rewrite the final answer for this expression as x plus 3 times x plus 1. Let's try another exercise. Factor the expression y plus 1 quantity squared minus 4 times the quantity y plus 1. Notice there are two terms in this polynomial that have a factor of y plus 1. So we're going to let y plus 1 equal capital A, and we'll rewrite this expression in terms of A. So we start off with y plus 1 squared minus 4 times y plus 1. Notice we have that a value equal to y plus 1, so let's replace that. So we will have an a squared minus 4a. Notice now we have a common factor that we can pull out, an a. And when we do that, we'll be left with a minus 4. And now let's substitute y plus 1 back in. So we have y plus 1 times y plus 1 and then minus 4. And then we can combine our constants together. So we still have y plus 1 as our first factor, but then our second factor will be y minus 3. And notice this answer does indeed match the final answer here. Let's try 3 more exercises utilizing the substitution property in order to factor. So let's first start out by defining our common binomial factor in this first one. And let's define it as capital B this time because there's a lowercase a in this one also. So in order to not be confused, we'll use capital B this time. Let's classify capital B, or assign capital B, to equal z squared plus 5. In doing so, we will have a times capital B squared minus capital B. Notice we have at least one capital B in both of our terms. So we can factor a b out, and when we do that, we will be left with little a times capital B minus 1. And then if we substitute our b values back in, we will have a z squared plus 5 times a times z squared plus 5, and then a minus 1. Notice since we have this a outside of this set of parentheses in the middle, we should distribute it through to both terms to further simplify. So we will still have z squared plus 5 as our first set of parentheses, but now we are going to have az squared plus 5a minus 1. And none of these three terms can be combined together. So this is our final answer. Now let's try this next problem. Notice we have a common factor of x plus y. So let's assign capital A to be x plus y. So we can rewrite this as 3x times A plus 4y times A. Notice we have an A in common, so we can factor that A out, and we are left with 3x plus 4y, and now we can substitute A back in. And when doing so, we will have x plus y times 3x plus 4y. And that's our final answer for this problem. And now let's look at our last one. In this problem, we have an x minus y and an x plus y as two factors. Since they are not the same, nor is one, say, -1 times the other, we cannot factor this. So the correct answer for this one is cannot be factored. And here are the answers. It does say for the last one can't be factored, and our top two factored polynomials match what we have boxed in here.